Hi everyone, this is Dr. Omar. In this video clip I will show you how to explore your data and to determine whether it is normally distributed or not, whether it is skewed or not. That is in SPSS. Now what does skewness mean? It refers to asymmetry that deviates from the symmetrical bell-curved or normal distribution. As we can see here, the curve doesn't look like normal curve. Skewness means lacks of symmetry in distribution. Skewness value can be positive, 0 or negative. In normal distribution, the value of skewness is 0. That means that the median, the mode, and the mean are all equal. Positive value of skewness indicate clustering the scores to the left of the distribution. When the tail is away from the 0 figure and toward the positive values, then the skewness is positive, or the data are positively skewed. And in this case, the median is greater than the mode and less than the mean. Negative value of skewness indicates clustering of the scores to the right of the distribution. So when the tail is toward the 0 value, then the data are negatively skewed. That means the median greater than the mean and less than the mode. The further the value is from the 0, the more likely that the data are not normally distributed. It is really convenient to convert the S-score skewness scores into Z-scores for standardization using the formula given below, as the Z-score could be obtained by dividing the skew value by its standard error. Now, Z skewness value between minus 1.96 and positive 1.96 indicate normal distribution, and beyond this value distribution is not normal skewed. For purpose of hypothesis generation, the null hypothesis in this situation will be that the data distribution is normal, so the data are not skewed, so the S equal to 0. And the alternative hypothesis is that the data distribution is not normal, the data are skewed, and the S are not equal to 0. So we accept the null hypothesis when the Z value between minus 1.96 and positive 1.96, and reject the null hypothesis if the Z value beyond those numbers, 1.96 minus and 1.96 plus, or plus 1.96 and minus 1.96. Now, how can we really spot skewness in a data and observe it? So there are several different ways. The first one is to plot your data in a histogram and look at the pattern of distribution, whether the data are clustered to the left side or to the right side. Second way is to draw a box plot, and in the box plot, if the two whiskers are equal in length, then the data are normally distributed. If one of the whiskers is longer than the other, then there is a skewness in the data. A third way is through QQ plot. In a QQ plot, if you have positive skewed data, then the data are above the diagonal line, and if the data are negatively skewed, then the data are below the diagonal line. And the fourth method or way is through calculation, in which SPSS can calculate the value for skewness. Right, here I have 3 different groups: group A, group B, and group C, and I want to examine and look at the distribution of the data in all these 3 groups, and to check whether it is normally distributed or not, and whether there is a skewness or not in any of these groups. And as I mentioned before, there are several different ways to do that. either through plotting the histogram or QQ plot or the box plot, or through calculation in which SPSS calculate the skewness value and determine the value, and from that value to determine whether there is a skewness or not in your data. So we'll do the first one, which is plotting a graph of histogram. If we click in graphs and legacy dialog, scroll down to the histogram, click on histogram, reset this, and again we have here the ID and the three groups A, B, C. I'm going to move the group A to variable, and then I'm going to tick this box which saying display normal curve, and then I'm going to hit the button for OK. Again, if we look here, we can see that SPSS has generated a histogram and a curve on it, and as I can see, that's fairly normally distributed data in group A. Now we go back again and do the same thing for group B. And if we come here to look at this histogram in group B, as we can see, the data are clustered into the left side, and the curve here is not normally pill-shaped, pill-curved, but however it's more skewed toward the positive sign. So this is a positively skewed data. Now if we go again and do the histogram for the final group, which group C, and click OK. Again, here for group C, we can see that all the data are clustered into the right hand side, and the curve is not pill shaped, however it's tailed toward the negative signs. So this one is a negatively skewed data. So we have here a fairly normal distributed data with a pill-shaped normal curve. Here a skewed data that are positively skewed, and here a negatively skewed data. So this is the first way of looking at your data and exploring them through plotting histogram and looking at the distribution, whether they are normally distributed or positively or negatively skewed. Another way is we can really go through a chart builder and go for box plot, select and reset this box plot and select this one here, and then we repeat the same thing again for group A. And if we move group A to here and then click OK, the SPSS will generate a box plot. Again, as we can see from this box plot, the two whiskers are nearly fairly equal, and so that's indicate these data are normally distributed in group A. Now if we go back again and do the same for group B again, and as we can see here, group B is really a little bit deviated from normal distribution, as one of the whiskers, this whiskers, is longer than the smaller one. So the data are not normally distributed. And again, if we go back again and do it for the final group, we will also get another box. Sorry, that's the same group. We need to do it again for group C. Group C, we'll move group C here and then click OK. As we can see here, now the two whiskers are not equal, so that indicates that these data are not normally distributed and they are skewed. So data in group C are skewed and data in group B are skewed. The third way is to look at the distribution through plotting QQ graph, and I've had a video on that describing how to do that. If we go through, click on analyze and then click on descriptive, scroll down to PPQ, and then going to on the left hand side to move all the three groups into the variable group A and group B and group C, and then hit the button for OK. SPSS will generate a few tables, and then it will draw the normal QQ plot or the quartile plot. Again, for group A, we can see it's fairly normally distributed. For group B, as again it is curvy shaped compared to the diagonal, and in group C it's again curvily shaped also, and it is not normally distributed. The final way is through calculating the skewness, and to calculate the skewness of the data we have three different options, either through frequencies, descriptive, or explore. So we click on analyze descriptive data, and then we will choose the first one, which is frequencies. So what I'm going to do, I'm going to move all these three groups into the variable box. I'm not going to untick this because it will give me a frequency tables for all the data. So I'm going to untick it, and then for statistics I'm going to choose here the mean and the median and the mode, and also in the distribution tick the square or the icon for skewness. And we could also tick on description, standard deviation, and standard error of the mean if we would like. Then click on continue. On the chart, we're going also to get histogram with showing normal curve in it, and hit the button for continue. In the format, we are going to leave everything as it is, and in the style we are not going to change anything. And if we click the button for OK, again SPSS in the frequency options will generate a table for group A and P and C, do some statistics, and it will calculate the mean, the median, and the mode for all the three groups. And if you follow the description and the PowerPoint I had made, you will really, that will make sense when we look at the mean and the mode and the median. Again, the SPSS also generate a skewness value for all the three groups. For group A, the skewness is 0.049, which is really fairly close to the 0. It's not further away from the 0, it's 0.05. So this fairly can indicate that these data are nearly normally distributed. However, group B and C, as you can see, it's 1.3, positive 1.3. So is positively skewed, and group C is minus 3.117, which means negatively skewed. Again, SPSS generated the skewness value for each of these groups. And again, if we want to do the scoreness, z-score for all the three groups, we can really work it out, as we have said, is dividing the skewness on the standard error of the skewness, and then getting the z-score, and then comparing the values. Again, the frequency options also give you the normal distribution of the curves, normal distribution and curves for each group. Group A, as you can see here, is normally distributed fairly. Group B is skewed, and group C, again, it's skewed. Now this is one of the options. Again, if we click on analyze and click on descriptive, and then now choose the option for descriptive, reset this, I'm going to move all the three groups into the variable box, and then in the options I am going to select standard deviation. We don't need maximum and minimum, standard error, and you need to click on the skewness options here icon for distribution, and then hit the button for continue. For style, we keep it as it is, and then we click on OK. Again, the SPSS will generate a descriptive table here for group A, B, C, and saying that there are 100 items in each group or score. Let's give you the mean for each one of them and the standard deviation, and it's worked out the skewness and the standard error of the skewness. For group A it's 0.04, and for group B it's 1.3, and for group C it's minus 3.1. The final way also to look and check for calculate and explore your data is to choose the options from analyze, descriptive, statistics, explore 1. So if we reset this, and then we're going to move these 3 groups, move them into the dependent list, click on statistics. Don't think we are going to change anything here, just we keep it as it is. In the plot, we're going to untick this, we don't need this stem and left. We're going to take on the histogram and then normality, plot with test, click continue. In the option section, we're not going to change anything. Here in the display, we're going to have both statistics and plot. Hit the button for OK. SPSS will generate a few tables and few charts. Here we can see the cases summary for A, B, C as 100 scores in each group. Again, in option of explore in analyze, the table is generated for group A and B and C. The mean is calculated, the median, and the skewness with its standard error for each group. And again, it is similar to other options in SPSS. And if we just hit here quickly, if you are familiar with the test of normality, again, I have already described these 2 tests, Shapiro-Wilk and Kolmogorov-Semenov in a separate video. The group A, it shows that it's normally distributed, and B and C it's not. The SPS also generated histogram for all the 3 groups, a histogram, a QQ plot, and also a box plot. So in this histogram, again, it's fairly distributed, and if we want, we can really click on the double click on the graph and then go to elements, insert a curve, and then we have now a normal distributed curve above this histogram. And again, we can see from the QQ plot that it's nearly normally distributed, and from the box plot, the data, the whiskers are nearly similar. And the same thing for B and group C. So in this way, I had shown you several different ways of how to explore your data and to determine visually whether they are normally distributed or not. Visually and through calculation, statistically. Visually through drawing a chart for histogram, a QQ plot, and a box plot. And through calculation, SPSS will calculate the skewness value for each group you have.